All right. Skill number 6. Some more formula stuff, but this time sort of looking back at some of our geometry formulas, in particular a volume formula. Excuse me. So this example is asking us to manipulate the volume formula for a cylinder. That formula we all know and love. Pi times r squared times the height. Pi times r squared, of course, is the area for a circle, right? So our volumes are always that sort of base area times the height. Pi r squared is our circle area times the height. So you want to take this formula, this volume formula, and solve it for the radius. So you're trying to unpack it all the way to get to this r value. Excuse me. So how are we going to do that? Same kind of strategy, same sort of techniques we were using before, trying to sort of divide and multiply to sort of shift things around. If I kind of rewrite this, right? So our volume, pi times r squared times the height. So the first move here is you'd like to get the sort of r squared at the very least by itself. So you're going to divide away the pi and the h from both sides. So that's going to look like pi times h on the bottom if you're sort of dividing by the both of them, right? To cancel them out. I'm sort of rewriting what's already here, but that's the idea. You're going to get then the volume divided by pi times h is equal to the radius squared. So okay, that's almost the formula for the radius, but it's radius squared. It's not just the radius. How do I get rid of this square? And the answer is you take a square root, right? What's the opposite of squaring something? And the answer would be taking a square root. So we're going to take the square root of both sides. That's what's happening here. We're sort of just throwing this on top. The root and the square cancel each other out, right? So this is just my single r. And then the other side, right, this volume divided by pi times the height, it's just the square root of that whole thing. But it's not really a way to sort of clean that up. We're not going to try to do something where we're doing roots of part of it or anything fancy. We're just going to kind of leave it as is. So this is a rearranged version of that volume formula. And you could imagine sort of doing this where you're solving for the height instead. In theory, you could solve for pi, but of course pi is supposed to be just a constant, so that would sort of always be the same number. That wouldn't really be much of a formula, I guess. So any of those things are possible. You could do this for triangle kind of stuff, rectangle kind of stuff. Any of those different formulas, this kind of technique would work. So what might this look like in action? So we saw cylinders, of course, when we talked about engine cylinders and displacement. So I wanted to look at number 13 from the exercises. This has a whole lot of different stuff going on. This has a mixture of some unit conversion stuff. It has geometry stuff, this sort of algebra, sort of rearranging kind of stuff. This is a little bit of everything. So I want to sort of run through this. The question says manipulate the volume of a cylinder formula, right? So the volume formula for a cylinder to determine the diameter in centimeters of each cylinder in a 2-liter 4-cylinder engine. So, okay, we're going to have to sort of unpack what this sort of means, right? Each cylinder, right, each has a 3-inch stroke. So each individual cylinder has a 3-inch stroke, and they're giving us a hint here, right? So 2 liters is the displacement of all 4 cylinders, right? So a 2-liter engine is the displacement of all the cylinders together. And one unit conversion, 1 liter is the same thing as 1,000 cubic centimeters. So let's say we've got all that information kind of rewritten, right? So find the diameter of a cylinder, 2-liter 4-cylinder engine, right? 2-liter engine, 4 cylinders. Each cylinder has a stroke of 3 inches. 1 liter is 1,000 cubic centimeters. We're definitely going to need a conversion between inches and centimeters, right? Because we have the stroke in inches, but then the rest of these values what we want are centimeters. And of course, liters, right? A 2-liter engine. Liters is a metric unit, and we're sort of given this conversion between liters and cubic centimeters. So honestly, before we do anything else, let's do that conversion from MA105. Hopefully we sort of remember this conversion exists, and maybe we sort of check back in our notes. What we had used is 2.54 centimeters is the conversion into 1 inch, right? So every 1 inch is 2.54 centimeters. So let's just do a quick convert. So 3 inches to centimeters. So that's kind of 3 inches over 1 times, right? 1 inch. This is really just a quick multiplication, right? 3 times this 2.54. That's going to be 7.62. centimeters. So that's the stroke, right? Which is the same thing as the height of the cylinder. Let's get a couple more pieces of information. So each individual cylinder, right? So 4 cylinders, 2.0 liters, total volume, right? So the size of the engine is the size of all 4 of those cylinders together. Now I want 1 cylinder, right? So that means I'm just going to do 2.0 divided by 4. So that's going to be 0.5 liters of volume per cylinder. So that's getting us somewhere. I need 0.5 liters converted to cubic centimeters, right? So that's where I'm going to use my 1,000 cubic centimeters for every 1 liter. This is sort of obviously 1/2, so that would be 500. In theory, right, to sort of do this more officially, you'd say, okay, blah, blah, blah. Every 1 liter, right, is 1,000 cubic centimeters. So 1,000 times 0.5, of course, 500 cubic centimeters. So that's the volume of each cylinder. Oh, I'm sorry. I talked through that, but I didn't really have it showing so well. So 0.5 liters into cubic centimeters, 0.05 liters, right, times, right, 1,000 cubic centimeters per liter. You probably can sort of justify this without even really doing this setup, right? It's half. Half a liter would then be half of 1,000 is 500 cubic centimeters. So what's our volume formula? So volume of a cylinder should be pi times r squared times the height. The height value, of course, is our stroke. In centimeters was 7.62. And what we're trying to solve for here, what we're trying to solve for is the diameter, but we're going to get the radius first. Let me sort of just sub these values in. In theory, we could do sort of an algebra version of this. We've kind of done that a little bit already, right? Where you sort of have the radius. So let me sort of show you what would happen if we sort of subbed our values in and kind of undid it that way. So this volume is 500. So that's pi times r squared times our 7.62. So, right, to unpack this, try to get to this radius, I'm going to do a division by the 7.62. Divided by 7.62, 65.6. That would technically be centimeters squared because we divided cubic centimeters by centimeters. Pi r squared. Pi, of course, is really just 3.14, right? So I'm going to divide by that as well. Divide by the 3.14. .6 divided divide by 3.14, something smaller, 20.9. So equals what? R squared. So how do we get rid of a square, right? We're going to take a root. So let's root both sides. Root of 20.9 would equal the root of R squared, which would be our radius. I'm going to use, so root 20.9. So 4.57. I'll use both of the decimals there. And that's centimeters, right? So that's my radius. What I want is my diameter, which of course is 2 times the radius. So that's 2 times 4.57 centimeters. 2 times 4.57, 9.14. So that's my diameter, which of course, in automotive language, is the bore for the cylinder. So that's a lot of unpacking. Honestly, I mean, that sort of took a minute to get to. That sort of was a whole page worth of calculations. Part of that is just all the different sort of unit calculations that were involved. But we're really sort of using little bits of everything there, right? We sort of have the geometry stuff. We're doing these algebra, this rearranging the formulas. In this case, sort of once we even have some of the numbers put in, we're sort of using those techniques though. Yeah, and it kind of all comes together. So all with an automotive spin. So there you go. That's the kind of stuff that you see in chapter 6. So some of the formula stuff. It's all about sort of doing this sort of unpacking and sort of repacking, and getting everything reorganized to help you out. There you go.